Here is the fourth step where you find what you're asked to find. And that total solution is equal to the natural solution plus the forced solution. Now is where you're going to match initial conditions. So here's where this is C1 cosine of 8t plus C2 sine of 8t. Now, if there was a non-zero forcing function, that's when you'll get, I have no idea how that happened. If you had a non-zero forcing function, that's when you're going to get, we'd have a completely different answer if you tried to solve for your unknown coefficients at the natural solution step. Here, it happens to be the same because there's no forcing function, but in general, it will be a different answer. So let's do it. Let's find these unknown coefficients by matching initial conditions, and let's solve for I at 0 plus. So our initial conditions say it's equal to 0, that we solved way back in step 1. Connor, what does our equation here become for time equals 0?
It should just become C1 plus 0 equals 0.
C1 plus 0 equals 0, so therefore C1 has to be 0, and that we could actually just plug that into our equation now and simplify it a little bit. We know that I is entirely sinusoidal. There's no part of I that isn't sinusoidal. It has to be sinusoidal because only a sine will give 0 response at time 0. We know it has to start at time 0. So now we want to find its derivative. And from our initial conditions, we know that its derivative is equal to minus 80. Connor, just finishing up. What's the derivative of this?
It should be negative 8 C1 sine 8t plus 8.
And there's the question, is it positive 8 or negative 8? I always forget. So my mnemonic is disk. If you can just remember disk, you'll never get this wrong. Disk says the derivative of sine is positive cosine. So we want to take the derivative of the sine, so we're going to get a positive cosine, and that's positive 8 C2 cosine of 8t. And so at 0, that becomes, oops, I have too many equal signs in there. So at 0, that becomes minus 80 equals 8 C2. So therefore, C2 equals minus 10. And now we've got our whole solution. I is equal to minus 10 sine of 8t amps. Just to clarify my little shortcut here, the reason why disk is so useful is that you can figure out everything from this. If you wanted to find out, you know that if this is true, then the opposite has to be true. So the integral of cosine is equal to a positive sine. It just sort of follows. And if you know that the derivative of sine is positive, then that means the derivative of cosine has to be the opposite, has to be minus, has to be equal to minus a sine. And all that just comes from remembering this one mnemonic disk. Okay, any questions on what we've done to solve this multi-step problem? We began. Is this the end of class? Did we finish class, or do we have another 4 minutes?
This is the end of class. Oh no, we have 4 minutes.
Okay.
We have 4 minutes.
Excellent. So I'm going to make it more complicated. What would happen if I said find now that you found I, what could I do to make this more complicated? I could say
Find all I of all time.
I could say find I of all time. That's pretty straightforward. What would that be? This is for time greater than 0 or equal to 0. What's it for time less than 0? Go back to your initial conditions. And you can see it's I of 0 the very first step, I is 0 for time less than 0. And I know that Philip is always interested in writing it in a single form rather than in this parts definition. So you could simplify that to say it's equal to this for all time. Sometimes it doesn't work out that nicely, but here it certainly does with the U of t. How about a harder question? I want you to quickly find before the bell rings VC. How would you go about that if you've already found your I? Quick, check your simple things. Can you just take a derivative of something and have it work? Can we take the derivative of your I and make it work to find VC?
Take the integral.
Ugh, you don't want to take integral, so.
No, that would be.
Because then you have to find also initial conditions, which you could do. And we've actually found the initial condition, it's 20. So that's one way to do it. You could say VC is equal to 1 over C times the integral from 0 to t of your I that you found out, d tau, plus your initial condition. And your initial condition was 20. You could do that. Is there a faster way?
You take the derivative of I and then multiply it by L.
Well, you could do that. And then would that find VC, what you're asked to find? This is one method. Here's another method. V sub L is equal to L I prime. Now you're asked to find VC. Is VC the same as VL?
No.
VL would be negative VC.
Yes, that's exactly correct. VL is negative VC. And to see that, go to this picture of what's going on for time greater than 0. And if we put in the way we've defined VC in the very beginning and VL in the very beginning, you can see that for time greater than 0, these guys are connected. They're just opposite signs. So therefore, we could say VC is equal to minus VL. So this would be the two steps we do. I mean, hey, algebraically, you could just combine them into one. Say it's minus L I prime. And this is the way that I would do it. This is a whole lot prettier and easier than trying to take the integral. Although the integral isn't really all that horrifically difficult either. Okay, any questions about any of that? That is, and this again would be true for time greater than or equal to 0. And you'd have to figure out what it was for time less than 0 by going back to your original picture for time less than 0 and reading it off. And it's pretty clear. It's 20 for time less than 0. Okay, that's all I've got for this lecture. We covered a lot of ground, and I think we ended right on time.